This lesson is on absolute value equations and inequalities. And before we get started on solving the equations or the inequalities, I want to remind you about what the absolute value symbol is and what it means. So remember that the absolute value means the distance from zero. We often say the absolute value makes the value inside the bars positive. Although that's not the best definition, it does help students to remember it. For the absolute value of 15, the distance 15 is away from 0 is 15. Or just keep the 15 positive. For the absolute value of negative 15, how far away is negative 15 away from 0? Well, it's 15 units. And since distance can't ever be negative, it's positive 15, which as a shortcut, students often like to think the absolute value of a negative is just equal to the positive part. So first we're going to solve absolute value equations. I have two very simple absolute value equations here to explore first, and I want you to think about these and try to solve them in your head. What value for x satisfies the equation the absolute value of x equals 3? What number could we substitute in for x such that the absolute value of that number is equal to 3? Well, the absolute value I know of 3 is equal to 3. I also know that the absolute value of negative 3 is equal to 3. So the solution to this problem is x is equal to 3 or negative 3. Well, let's take a look at the next one. What value for x is going to satisfy this equation? What number can I substitute in for x so that the absolute value of that number equals negative 3? Well, we've already discussed that the absolute value of positive 3 equals positive 3, which is not going to satisfy this equation. We also know that the absolute value of negative 3 equals positive 3, again, which is not going to solve this equation. There is no such number. When you take the absolute value of it, you get a negative 3. And that's because whenever you take the absolute value, you either get something positive or you get 0. So something positive or 0 is never going to equal negative 3. So the solution to this problem is no solution. Notice on those last two examples that the sign on the value determines if the equation has solutions or not. The absolute value of x equals 3 had two solutions because the 3 was positive. The absolute value of x is equal to negative 3 didn't have any solutions because the sign on negative 3 was negative. So it didn't have any solutions. So we have two very different cases here. Let's take a look at the steps for solving absolute value equations that are a little bit more difficult than the ones we just looked at. The first step is to isolate the expression in the absolute value bars. We would like it to look like expression is equal to some value c. Now we have two cases that we're going to consider. If c is non-negative, which means positive or 0, and then we'll talk about what we do there. But the other case is if c is negative. And then we do something else there. In the last two examples, we saw that if c was positive or if c was negative, we have very different solutions. So you have to treat them differently. Let's go back to if c is non-negative, which means positive or 0. So we're including the 0 case in with the positives. What I want you to do is to split the absolute value equations into two equations without absolute value bars. And the two equations are going to be your expression inside the bars. You take it out of the bars and make the expression equal to c. Or the other equation, which also works, is the expression equal to the opposite of c. And then you would solve those two equations. Now let's take a look at the instructions if c is negative. As in the example before, if c is negative, then the answer is no solution. Because when you take the absolute value of any expression, it can never be equal to a negative value. So I like this one because the answer is just no solution. Okay, for this first problem, let's make sure that my expression in the bars is isolated, and it looks like it is. Now identify if C is either non-negative or if it is negative. In this case, 11 is positive, which means non-negative. So I'm going to split it up into two equations without the bars. The expression is equal to 11, or the expression is equal to the opposite of 11, or negative 11. From here, I have two linear equations that I can solve fairly quickly. I'm getting x is equal to 7 on the first one. And x is equal to negative 4. So my solution set is 7 or negative 4. On the next example, my expression is not yet isolated. So before I can start this problem, I need to isolate my expression. I'm going to subtract 7. And then divide both sides by 4. And now my expression is isolated. So the next question I ask myself is C negative or non-negative? In this case, my C is negative 1. So that means it is negative. So I can stop my problem right here and say that my answer is no solution, because the absolute value of any expression is either positive or 0. Can positive or 0 ever be equal to negative 1? Well, the answer is no. That can't ever be possible. So my answer is just no solution, or the null set. Two more examples for you. In the next problem, I have to isolate my absolute value bars before I can start my problem. So I would like to subtract 2 from both sides. Divide both sides by 7. And then I identify, is C negative or is it non-negative? Meaning 0 or positive. In this case, my C is positive. So I can break it up into two equations. Either 3x is equal to 2, or 3x is equal to the opposite of 2, or negative 2. Solve by dividing each of these equations by 3. And my solution set is 2/3, negative 2/3. On our last problem, I would like to isolate my absolute value bars. So first I'm going to subtract 7 from both sides. And divide both sides by 2. 0 divided by 2 is still just 0. Once my absolute value bars are isolated, I ask myself the question, is C negative or non-negative? Well, in this case, C is 0. What does 0 classify as? A negative number or a not negative number? Well, in this case, it's not negative, or we call it non-negative. So I'm going to split this equation up into two equations without absolute value bars. The expression equals to 0, and the expression is equal to the opposite of 0. Although negative 0 is a little silly, isn't it? We never use negative 0 because 0 is neither negative nor positive. So this is actually the same equation, and really I would only need to solve one of them. This is a little bit redundant. So now I will solve the equation 3x is equal to positive 1. Divide both sides by 3. I'm getting x equals 1/3. You're welcome to solve the other equation if you'd like. It's still going to get you x is equal to positive 1/3, and that is my solution set. Next we will look at interval notation. Interval notation represents the set of all numbers between two endpoints. If you would like to include the endpoint with your solution, then you need to use a bracket symbol. If you would not like to include the endpoint with your solution, then use a parentheses symbol. We always write our interval notation as follows: the lowest value, comma, the highest value. These values are your endpoints, and we include all numbers in between them if we're using interval notation. Use your parentheses or bracket before to denote if you're including the lowest endpoint, and use a parentheses or bracket after if you're going to include or not include your highest value or your highest endpoint. Let's take a look at some examples. For the inequality notation, x is less than a. X can be any value as long as it is less than a. The way we graph that is we have an open circle at a, and we denote all the values to the left of a are all the values that are less than a. Similarly, if x is greater than a, we have an open circle and we shade in all the values to the right or greater than a. This is inequality notation in the corresponding graph. The corresponding interval notation would be writing the lowest endpoint, comma, the highest endpoint. Well, in this case, the lowest endpoint, there is no real endpoint here. The lowest value we can have keeps going and going and going and going all the way to the left as far as it can go. The symbol we use is negative infinity. Negative infinity is the lowest that x can be. The highest x can be is a. Notice that because we have an open circle, we do not want to include a, so we're going to use a parentheses. And we don't ever get to include negative infinity because negative infinity is actually not a value. It's more of an idea or a concept, so we never get to include negative infinity. We always use a parentheses on the infinities. Similarly, for x is greater than a, the lowest endpoint here on my picture is a. Comma, the highest endpoint, well, it doesn't really have an endpoint, it goes up forever, so we write infinity. A cannot be included, parentheses, we never can include infinity parentheses. Notice the next two, x is less than or equal to a, and x is greater than or equal to a. The difference between these two and the previous two is the greater than or equal to symbol. In this case, if x is less than or equal to a, I can include a and everything less than it. If x is greater than or equal to a, I can include a and everything greater than it. The interval notation here is negative infinity, that's the lowest it can go, comma, the highest it can go is a. Now in this case, because I can include the a, I'm going to use a bracket instead of the parentheses. On the next problem, we have a is the lowest endpoint, so it goes first, comma, the highest endpoint. Well, there is no endpoint there, so we're going to use infinity. I can include the a as a bracket. I can't include infinity, that's a parentheses. Notice that the next four have two endpoints, a lower endpoint and an upper endpoint. If a is less than x, which is less than b, in inequality notation, that tells us we have open circles on a and b, and I have all the values in between them. In interval notation, we simply write the lowest endpoint, comma, the highest endpoint. I use parentheses because I cannot include either endpoint. On the next problem, a is less than or equal to x, which is less than or equal to b. I'm allowed to include both a and b, and x is between a and b, sandwiched between it, so I'm going to include all the values in between a and b, including a and b. The interval notation is a, comma, b, bracket on the a with a bracket on the b as well because you're allowed to include both endpoints. The next two are a little bit funny because one of the symbols is less than, where the next symbol is less than or equal to. So we have an open circle on a, but we have a closed circle on b. X is still between them, so all the values between them will work. My lowest endpoint is a, my highest endpoint is b. I am allowed to include b, so I use a bracket on b, but I'm not allowed to include a, so I have a parentheses on a. Some students don't want to use a parentheses and a bracket on the same interval, and you are welcome to do that if that's the case. On the last problem, a is less than or equal to x, which is less than b. You're allowed to include a, but not b. So a is the one that has the bracket and b does not. The last two are some special cases, all real numbers and no solution or no values in our interval. If your answer is all real numbers, your graph would have all values shaded. And the way we write that in interval notation is negative infinity, comma, positive infinity. This is the way we write all real numbers or all real solutions in college algebra. For no solution, you wouldn't shade anything on your graph, and your answer would just be no solution, the null set, or the empty set. Or technically you could write no solution. We will be using interval notation several times this semester, so be sure to use interval notation to answer all your questions instead of inequality notations throughout the rest of the semester. Next, we'll look at solving linear inequalities. This is just a quick reminder of the inequalities that you've learned in previous algebra classes. I'm only going to show you two examples that I want you to remember because we will be using them later on when we're solving inequalities with absolute value. Solving linear inequalities is not really part of this curriculum, but I really wanted to review it just so that we can use some specific examples. Remember from your previous algebra class that you only switch the inequality sign when you multiply or divide by a negative. And that is super, super important. Or if you rearrange the equation. Looking at the first example, negative 4x plus 3 is less than or equal to 27. To solve this equation, basically treat the inequality sign similar to an equal sign until the step where I divide both sides by a negative. And this is one of those cases where when you divide by a negative, because the thing that we are dividing by, is a negative, you have to switch your inequality signs. Notice that when I subtracted 3 from both sides, I didn't switch my sign, because that wasn't multiplying or dividing by a negative. It was subtracting, but that wasn't multiplying or dividing by a negative. When I divided by this green negative 4, that's when you need to switch your inequality symbol. Let's just finish this out by graphing it. If x is greater than or equal to negative 6, I'm allowed to equal negative 6 and be greater than it. And the interval notation is negative 6, the low point, comma, the highest point, which is infinity. And I'm allowed to include my negative 6. So this would be one case where you switch your inequality. The other case where you would switch the inequality is if you rearranged your equation. So for example, negative 2 is less than x. This is completely solved in inequality notation. Although I find it somewhat difficult to graph in this form, I prefer to have the x in front and the negative 2 in back. Are you allowed to rearrange that? Absolutely, as long as you switch your inequality. So your alligator is eating the x, so your alligator also has to eat the x here. So notice I switched the signs, and you're allowed to do that if you would like to. You don't have to. This is one that you don't have to do, but if you would like to rearrange them, you have to switch your signs. Let's finish this. X is greater than negative 2. That's an open circle at negative 2. And my interval notation is negative 2, comma, infinity. I'm not allowed to include the negative 2, so it's a parentheses.